Well, now we know where space is and what space is. How do we stay here once we've arrived? Well, 300 years ago, an English scientist, Sir Isaac Newton, figured out a way to do this. He began by showing a very high mountain. The imaginary mountain was so high that its peak poked above all the atmosphere. He put a cannon on top of the mountain and fired cannonballs. We'll use baseballs. Okay, here's our imaginary mountain. Let's pretend that we can climb to the top of this mountain with a sack of baseballs. Now, if we throw one of these baseballs straight out from the top of the mountain, would it go straight out like A, fall straight down like B, or fall in a curved path? While C is correct, the baseball would fall on a curved path. Even on this tall mountain, it still feels gravity. This is because the ball has two motions acting on it at the same time. It's trying to go straight out, and it's also falling toward the earth. The result is the baseball travels on a curved path and lands right here. Now let's throw another ball, only this time much faster. See, it goes farther than the first. If we throw another ball even faster than the last one, it goes farther still. So the faster we throw the balls, the farther around the earth they go. Now we'll take our last ball and throw it as hard as we can. Just like the other balls, it falls in a curved path. But this one is moving so fast that it circles the earth. We'll have to duck to miss it. But it won't be safe to stand up for a while, because unless something gets in the way, the ball will continue to fall around the earth on a curved path. We call this an orbit. Of course, the space shuttle doesn't launch from a mountain, but we still need a lot of speed to get into an orbit around the earth.
So, how fast do we need to be going to get into orbit? Well, if the space shuttle had a speedometer like the one in your car,
it would have to get all the way to 17,500 miles per hour to make it into space.
So how fast is that? Well, it took the early pioneers months to cross the United States by wagon. It took the first transcontinental trains a week to cross by rail. It would take about 3 days of driving round the clock to get across by car. And it takes about 5 hours for the average airliner to fly coast to coast. But on board the shuttle, we cross the country in 10 minutes. That's about 5 miles a second. You see, the space shuttle goes around the Earth 16 times every Earth day. That means we see a sunrise and a sunset once every 90 minutes. This could be a problem. Up here on the orbiter, if I woke up when it was light, and went to bed when it was dark, I'd be getting up and going to sleep every 45 minutes. That wouldn't work.
So instead, we just plan out our days like we would on Earth.